Hey, hi everyone. Welcome to HNM Technologies online training. So this is the video 55 NumPy basics. You know Python lists. NumPy arrays are look like similar to the Python lists, but they are up to 100x faster for numerical data and are a foundation for every data science library. So NumPys are basically complex numericals in a faster way compared to the Python or math operations. And also it's a very foundation, and most of the data science libraries like pandas, matplotlib, tensorflow, all everything is built on a numpy. So let's get started. For this you need to install numpy. So for this, as usual, pip install. You need to run this pip install numpy in a terminal. So see here, I run command pip install numpy, but it's, for me it's already installed, and that's why it gave me command like this: pip3 install upgrade pip. So you may get a like this. If it is a command not found, then use a pip3 install numpy, and you get a successfully installed numpy latest version. Okay, so the installation part was done. Next, section 1, which is arrays versus list. Now let's understand why numpy is so powerful. First, we create a normal Python list with a million numbers. Then we multiply each element by 2 using a loop. This takes some time because the Python processes each element one by one. So now let's see. Firstly, use a basic Python math function. For this, I need to import a numpy as a np, and I'm also importing a time. Now let's say Python list. Next, we create a numpy array, which is a very fast. Let's compare the both. Now look at the line. This line result equal to np array into 2. Here numpy applies the operation to all elements at once. You can see in a Python we need to loop this operation to each value inside our Python list. In numbers this operation called as a vectorization, because the numpy is implemented in a optimized C code. It is much faster than the Python loops. So let's run this. You can see the output list is a 0.034. So Python list are slower for numerical operations, and NumPy is much faster and efficient. Now let's learn how to create a NumPy arrays and understand their basic properties. First, we create a simple array. So creating a variable called a and np, that we a module installed NumPy as a np. So np dot array, and we can also create arrays with decimal values like movie ratings. Now let's understand some important properties. So firstly I'm printed a array which is 1 2 3 4 5. So this is my array, and then I print a type. A dot d type tells which type of array it is, and a type of elements an array, and shape tells us the dimensions of the array, and size tells total number of elements in a array. And next, number provides a built-in function to quickly create arrays. So let's see this: arrays of zeros, ones, and with a range. So zeros, np dot zeros of 5, and ones, and also with the help of a range we can print np dot a range of 0 to 10 with a step value 2. And let's print our ones and zeros. You can see 5 zeros and 5 ones, and a range with a 2 and 0 2 4 5 with the help of index step value is 2, 0 to 10, and the step value is 2. So you can see np dot arrange, it looks like a range, but it returns a numpy array. So there is a difference, arrange and that one is a range. Okay, and this is a very useful for generating sequences. Okay, and these are the basic building blocks you'll use in almost every NumPy program. Next, section 2, which is indexing, slicing in math. You must say indexing, slicing, list slicing, and indexing and math operations in list. But in arrays, it performs operations in a NumPy arrays. So we have a ratings, which is an np data array. This represents a movie ratings. And firstly, you see indexing, and as usual, index number starts from 0, 0, 1, 2, 3 like this, and printing first ratings. Ratings index number of 0, it returns 9.0, which is the first element in a array, and as usual last element index number -1. Okay, this means arrays are can perform an negative indexing too. and next slicing. So I'm printing first three. So first three means 9.1, 8.8 and 8.4. So 9.0, 9.8.8, 8.4. So first three you can see 9.0, 8.8 and 8.4. So first three, and the last two, which is a -2 and index number up to end. So this means 6.5 and 9.1. So this way you can fetch the elements from the array. So arrays can perform a slicing also. Now comes the powerful part, vectorized operations, math operations. So I'm just adding a +1, that means increasing every rating into one value. See, 9 is 10 and 9.8, 8.4 is 9.4 and 9.1 is 10.1. Everything one value is increased all at a time. And also can see multiplication. So every rating is multiplied with 2, and we're going to round it and put out round ratings. So 999. So every rating is a round figure to the nearest value, 9, 9 and 8, 8, 6, 9, like this. And next, statics. Number provides built-in functions like max, min, mean, and standard deviation and sum to get a total. See, all at a time. I'm printing a max of max rating and 9.1 minimum rating and mean value, which is 8.22 something, and also standard deviation and sum total of all ratings are 57.6. And finally Boolean filtering, and the ratings inside ratings greater than 8.5. This creates a condition. NumPy selects only those elements that satisfy it. Now see the top rated here, 9, 8.8 and 9.1. Those are above the 8.5. This is extremely useful in a real world data analysis. For example, selecting a top rated movies. So in here we filter the data using conditions, not the loops. So number always lets you think in terms of data, not in terms of loops. Section 2, which is a 2D arrays. Now we are moving from 1D arrays to 2D arrays. A 2D array is like a table. Rows represent movies and columns represent critics. So we create 3 movies, 4 critics rating, each rating matrix. Create that. So here we have 3 movies, Triple R, Bahubali, KGF, and 4 critics, 1, 2, 3, 4. So shape is 3, 4. That means 3 rows and 4 columns. We can access the data using row and column indices. Now let's access the data. So I'm accessing first row, which is a rating matrix of a 0. This returns a triple or critics first row. So I'm printing a rating matrix of a 1, 2. So this is 0. This one is 0, and this one is a second one is 1. Second one is a 1. Index value starts from a 0 always, and I'm giving a 1. So from this, and this is 8.8 is a 0, 9 point is 1, 8.6 is a 2. So I got a 8.6 in output terminal. So first one, row 1 and second critic. We have 3 rows and the index number is 0, 1, 2. Now let's calculate average. So here you can see axis 1 means we calculate across column 1 per movie. That means per movie. So we have critic ratings per a critic axis 0. Axis 0 means we calculate down rows. That means average per critic. Now you can see the output terminal is average per movie is this one, and average per critic is this one. So to calculate average, we use mean, and finally axis 1 means movies wise average, and axis 0 means critic wise average. This is how we analyze structured data using NumPy. In section 4, real use. So in real world, we are using a box office analysis. To build a real world box office analysis, let's apply a NumPy to a real world problem. So which is a box office analysis. We have movie names, collections, and budgets. First, we calculate a return of investment, which is a ROI, return of investment for each movie. See, instead of using a loops, we calculate ROI for all movies at once using a NumPy. Then I have printed a heading box office report that you can see in output terminal here. Now we print a report showing each movie's collection and ROI. For this, I'm looking for to each movie, You can see output terminal triple or 1200 crores, and rate of interest is 1.18 118.2%, and for Bahubali 2 rate of interest is 624.0%, and Pushpa 2 rate of interest is 414.3%, like this. So the rate of interest we calculate using collections and budget, and then we compute some insights like total industry collection using np.sum, and highest rate of a return of investment using np.argument max, you can see. And also we created a number of movies performing above average, so collections are greater than mean collections. And here is output, completes box office report and movie and the budget and return of investment, and here total industry and highest rate of interest and above average two movies. This is how NumPy helps us quickly analyze real world data efficiently. And let's say practice questions. Three different levels: beginner, intermediate, advanced. In beginner, we need to create a NumPy array of 10 student marks and find the max, mean, and print all marks above 70. And in intermediate, you need to create a 5 by 3 matrix where each row is a movie and each column is a different review sites ratings, and then calculate the average rating per movie, average per site, and find the overall highest rated movie. In the advanced, which is a challenging level, and load a box office data from a CSV into NumPy arrays, calculate a return of investment for each movie, and rank them, find a top 3 performers, and print a formatted analysis report. This may challenging you, and this advanced level is well, must and shouldly give you a fun and challenging too. So you need to must and try these practice questions. So in this video we done NumPy arrays, creating an NumPy arrays, and we also see the np dot NumPy array and zeros ones, the easiest way to create sequences, and we also see the slicing of arrays and boolean filtering and statistics like mean, max, mean, and standard deviation and sum. And we also done creating a 2D arrays, and finally we saw the access operations, which is 0, access 0, and access 1. This is all about this video, and the next video we're going to learn pandas basics, the most important data tool in Python. See you there. Thank you for choosing HNM Technologies online training. Happy coding. Bye bye.